All right, so chapter 2, section 7. Um, Almost getting done with chapter 2. And so this one, we're finding derivatives, dy dx, but they look a little different. So the derivatives that we've been doing previously have been explicit. Y has explicitly been solved for x. In section 7, it is not explicitly solved for x. It's an implicit differentiation. So when we're looking at, something like number 1, I would probably just add y to the other side, and you end up with some equation that looks like, let's slide that over. I'd have y equals 4x squared plus 4x, and minus 4x, sorry. Again, you're going to subtract the 4x, but then add the y to the other side, and now it's y explicitly solved in terms of x. And we would just derive this and say 8x minus 4. So again, that's what they have. On the next one, on something like number 2, like I don't know if I want to solve that for y. Try to factor it out, do all that. I may not even be able to. Like I want to try to graph this thing and see if Desmos will graph this for me. Some of the more complex problems it will, sometimes it won't. Equals 0. Ah, sweet. So we have this neat looking function, right? So this is pretty awesome. Notice, oh, I said function. I should not say function because it is not a function. It doesn't pass the vertical line test. I have a very neat looking equation. But it doesn't mean that there's not tangent lines along here, right? We can find slopes at particular points. Like right there I can find the slope of the tangent line, or right here I can find the slope of the tangent line. So just because it's not a function doesn't mean that it doesn't have a slope or a tangent line. It just means it doesn't pass the vertical line test is what it means. So if I want to find the derivative of something like this, I'm going to have to do it as, I'll make a supplement for this one, but I'm going to do it as, I'm going to look at this and take the derivative of each one of these things, and I have a product of things, so I have to use the product rule. So the derivative of x is just 1, and that's typically what we would write. The derivative of y is dy dx. Typically, whenever we've had a equation y equals blah, on the left-hand side we can put dy dx. So the derivative of y is dy dx. So we're just going to have to use all of our rules. And I'll show an example for one like number 2 and one like number 6. They've actually given us some equation, some implicit equation, and they derived it, and then they plugged in the value negative 5,5 to find the slope at a particular point on this equation. Again, not a function, because it's there'll be something, it will not pass the vertical line test. But we still can derive that. So I'll do a supplement for number 2 and for number 6.